and welcome to the Pluto 7 and Google webinar. We're going to talk today about supply chain and retail transformation with learning and the Internet of Things. So thanks for joining. We'll go ahead and start it. I want to introduce myself. My name is Angela Alejandro, and I am the Head of Sales and Marketing for Pluto 7. I'd like to also introduce you to our guest speakers today. First, we have Jonathan Cham from Google. He is a customer engineer. Thank you, Jonathan.
Good morning, everyone.
Thank you. We also have Manju Devdas. He is our CEO and founder of Pluto 7. Welcome, Manju.
Good morning, everybody.
Thanks. And for some housekeeping, we will be recording this webinar, so if any of you have to drop early, we'll be able to send this out to you afterward, or you can share it with your colleagues. Know that we will be doing that. There is a chat option available in the WebEx at the top right of your screen if you'd like to type a question. And then, of course, we will have live Q&A afterwards, at which time you can speak your question as well. So we will do that. Okay. About Pluto 7, for those of you who have not done business with us in the past, we were founded in 2005, and we are a professional services company that specializes in SaaS methodologies and cloud. We are a Google Cloud Platform partner and a Tableau partner, and I'd love to speak more about that when you have time. Just to go on, what is machine learning? This is a common question in the industry. Well, what exactly is machine learning? We'll have the experts talk to you about that, but from my personal perspective, I like sharing machine learning in action in our real daily lives. Many of us have Netflix and watch movies, and we get recommendations from Netflix on which movies to watch. An example might be the Narcos series on Netflix, which after a binge watch might get an experience as a user, something in your recommendations about the movie Pulp Fiction. And we have several examples here that you can peruse at your leisure, but the net of it is that in a real-life scenario, machine learning recommendations are actually telling the company, Netflix, what to tell the customer, you and I, after noting what behaviors are in their application and what things you're already watching. Just a quick intro into where it might be used. Now, the very representation of the path that traditional BI has taken over the years, and if you look at the bottom left, you'll see that most of the money in BI in most corporations is usually spent traditionally on data collection, data transformation, data storage. All of those things are very necessary and can't be gotten around. As you move more towards the up and right, what you're going to see is that as machine learning comes into the picture, instead of a typical BI scenario where you're writing the business rules for your data and then deciding what actions to take, machine learning actually creates those business rules itself as part of the technology and allows you to be proactive based on the information you receive. A very far upper right, when artificial intelligence is in the picture, now we're talking about technology that is creating business rules and also taking action for you so that humans don't necessarily need to intervene. So very high level, and of course we're going to get much deeper into this. So I will go ahead and turn this over to Jonathan.
Thanks for the introduction. Let me go ahead and share my screen real quick. And let me share my screen. My screen? All right. Yeah, so I'm excited to be here with Pluto 7. I mean, machine learning has kind of grown in interest over the last couple of years, and it's really because data exploding, right? We have all this data. What do we do with it? I mean, even for myself in the last year, I just started connecting my home with all these smart devices, and they're collecting all sorts of information. I have a Nest Cam, I have smart lights, I have a thermostat. Everything digital now. We're collecting all this information and trying to take advantage of all this information. Most data is unstructured, right? Unstructured data is most rated textual data. So, for example, Twitter feeds, blogs, you know, reports, projects. I mean, these are there's all this, and it's all unstructured. Whereas structured data, you have basically a taste, and you know exactly what each row is. Unstructured data is you don't know what it is, and machine is designed to figure out what is your data. So I think one of the really interesting things, and Manju, you've had a lot of experience as well, is I mean, machine learning itself is not new, right? I mean, the algorithms, the math, the science behind machine learning has been around for decades. But what in the last couple of years is that we've had the computational power to actually take advantage and process all information in a way that actually is useful. So, Manju, do you want to, talk about on, what machine learning is, from a historical perspective?
Jonathan. Well, my learning, given the different business models that we deal with, right, the likes of the Amazon.com or Netflix or Snapchat and so on. So it's used in whenever there's massive volumes of combination of data, either the products or customers, and where human computation is practically impossible to identify patterns. Where is another very common use case, weather forecasting. Identifying these multiple factors which drive recognition of, the actions that to take. I mean, that's where machine learning plays a huge role. With computation power that Jonathan is going to talk about, you see why this is all going to become real now. Go ahead, Jonathan.
Yeah, so exactly. So, like I said, the science behind it is not new, but the ability to come in and take advantage of all the processing power is, in the last couple of years with cloud and everything, has allowed us to uncover insight from all this data. Google, those to type in the woman pool. Use Google Photos all the time, and every time I search for, let's say, I'm looking for my baby, it's able to identify what baby is as opposed to a pride. It actually can see the size, shape of the body, and it'll tell you, oh, this is what it thinks is a baby. I mean, this is machine learning, in its simple form, right? And when I say simplest form, it's simple to understand, but obviously the algorithms and the models behind it is extremely difficult. We use machine learning. Google Translate. I don't know if anybody's used Google Translate. I used Google Translate when I was in Japan a couple months ago, and I'm very glad that it worked because I'm eating this sushi and I had to ask what am I eating here. So I did the translation, and he told me it was a sardine. So I was like, oh wow, I mean this does work. And it is like photos is easy to understand. You're translating one language to the other, but the animation is very difficult. Like, for example, there's like 20 different ways to say, to get in French. Any meanings of get that are English, but the French use it for many different things. And to take that into context as we do the translation is machine learning really is valuable. So machine learning. Yeah, look, we said everywhere, right? And do machine learning because it's fun. Maybe go a bunch of nerds that like to do random technical projects and to do fun things, but the reason why we do and we have machine learning everywhere is automation. We users and alien across 8 different apps. We can't really scale, apps to support 1 billion users, and because we have to have machines try to help humans and complement humans to do a lot of the work that we can do, right? And that's why machine learning is very valuable for businesses. Focus on building your business while automating what you can as much as possible. enterprise. I think all the data in one place is actually very difficult. I was working with one of the largest retailers, and I mean, that's a couple of years, right? They have data just everywhere, data sprawl, and getting that all into one place, figuring out which model to use into your business process, ensuring scalability and performance. I mean, this is the work of building out a good machine learning experience for your business. And this is need partners like Pluto 7. Self, absolutely. The question is, should you do it? I want to hire the mathematicians, the statisticians, the machine learning experts to build out these models for you. I mean, there's some interesting cases where you know, a very large company and you're going to be using machine learning for a very long time, building models day in, day out. But for the most part, you know, like Pluto 7, help you in the time to value for your machine learning. Many data warehouses, but we found that it's the foundation of something a lot bigger. You know, warehouses are used just to store all this data and run queries on it, right? Let's figure out what is the data, how to find some meaningful information. That's all great. But taking that data, providing machine intelligence, or using machine intelligence to uncover advanced analytics is kind of the future that we, as we work with all companies. I'm sure listening already have a use case for machine learning, but I think today we're focusing on supply chain, manufacturing, retail. I'm working with another company, and they're looking at a recommendation engine. I actually went inside, I bought a men's sweater, and the recommendation that they have was suggesting I get leggings and women's like sweater. And I said, why is it recommending me, you know, women's leggings? That makes no sense at all, right? So that's they're trying to improve with machine learning, is understanding, okay, if I'm buying a men's sweater, what's the context there? I'm probably a man, right? It'd be wrong. It could maybe be my wife buying it for me, but you know, it's probably a men's sweater. And what type of products should be based on being a male, maybe a medium sweater? You know, shouldn't be suggesting that I get XL pants if I'm buying a medium-sized sweater. So things that are all part of machine learning, understanding you know, consumer behavior based on the context that you're giving it. As you're around, you know, manufacturing, retail, I know you're going to go into supply chain later.
Back to what Jonathan said, while some of the use cases might sound very abstract and not relevant to us, be surprised on how many high-tech companies, we are based in Silicon Valley, and how many high-tech companies are actively looking at many of these use cases and saying, how can we apply? How can we get started with this? Right? As in, when you get into the actual conversation of what the business scenario is, it is less abstract and it starts getting more clearer. Go ahead.
Yeah, exactly. Buildings today involves a lot of, you know, right, three-step process that we've abstracted at a high level, right? You need the technology, you need to operationalize it, tooling. And it's, I mean, the most business have the compute power to train and run these models day in, day out. That's right, that's what Google Cloud Platform is for. We have our version of our platform called TensorFlow, which is kind of open source standard for learning. And the benefit of elasticity, right? You're training these models, they take, I mean, hundreds and thousands of cores. And businesses don't have that at their discretion. So technology obviously is very important. Operationalizing it, like how do you leverage machine learning and integrate it into your business process? There's different models, and the ML structure is in managing the infrastructure itself. The value is actually using the machine learning to build real value. And then tooling, there's all these different tooling around what's right and what's wrong. Is very distracting. So these are the different keys today in machine learning, and where partners like Pluto 7 really help customers understand how and where and when to use machine learning. So, perspective, we hosted a version of our machine learning platform called TensorFlow. And when I say hosted, it means is you really have your data, you point it to our API, which is our TensorFlow API, and you allow us to manage the infrastructure, the security, the updates, the patching, and the auto scaling of the processing needed to train your machine learning model. And that allows you to focus on your business, right? Managing infrastructure. If you've managing infrastructure today, you know how much time and money it takes to manage or operating systems. All of that adds no value to your business. And this is a model for machine learning. Visualize all these results. And GitLab, if you just do a quick Google search on GitLab, you can do a quote. I think free right now. Definitely take a look. This can plug into things like Jupyter Notebook, allows you to visualize information, and it's really easy to use. Really easy to use. And within our visualization product, everything's integrated with GCP. So in a Google platform, you have storage, you have BigQuery. These are all tools that you can use that are tightly integrated into the platform so that you don't have to kind of retool how you build our machine learning models. They're all APIs are integrated, consistent across our different products. So just a quick kind of workflow of where we see machine learning. You ingest data, you process it, you store it, and you have analytics. And we have different tools depending on your business needs. I'm going a little slow. It's already 30 minutes past. So, Manju, you're going to go into use cases that are really relevant and how you can apply machine learning to supply chain and retail.
So, grab the ball. So, can everybody see my screen? Okay. So, Jonathan gave you a background about Google Cloud Platform and the components and so on. So, we have been in the business for 10 years, and we have compared various public cloud platforms. For Google infrastructure, it's the same infrastructure that you run Google search, and I always wondered how does Google search works so fast and so well, where it can really relate what you're asking. It is the power of the machine learning and the powerful infrastructure that's behind it. It is the same platform that we are leveraging here for machine learning implementations with our customers. In my section, I will walk you through some of the practice cases that we are engaged in our conversation with our customers, as well as show a demo of a quick application that we built on the Google Cloud Platform. So, machine learning, there are a couple of key steps what we suggest you look at if you're looking at your own company adopting machine learning. The step is identify the right business problem. And now again, this is going to be the hardest, and we'll tell you confidently, right? Like most machine learning proof of concepts are going to fail because of not identifying the right business problems. And what do we mean by that? One rule of thumb that you want to use when you define a business problem is the number of computation that is involved in solving your problem very much? Is it practically impossible for a human being to analyze that in a set of dashboards? If the answer is yes for these, then you have the right machine learning problem. And for example, if you have 1 million products and 500,000 customers, you really practically sit and build dashboards to identify customer buying pattern and compare against 100 different customers and do it day in and day out, every single day, every minute, is humanly impossible. That's where you need this massive computing power as well as machine learning. And the next thing is beyond a business problem. You want to look at the models will best suit your business need. And there are here we have listed some of them, but these are the more common ones. Now, once you pick one of them, then comes you need to anticipate your output, and you have to be ready to also accept output that you would have not anticipated, right? So let's talk all of this in the context of retail and the supply chain businesses. In the retail businesses, this applies for some of the high-tech customers as well, whom we are dealing with. The most common application of machine learning is upsell, cross-sell, which is, okay, what an iPhone 6 or you're looking at iPhone 6, should we upsell to sell you iPhone 7, or you're buying iPhone and should we sell you headphones, which is a cross-sell. And then there are various other scenarios of, improving your forecast accuracy or pricing it right. If you think about pricing, for example, price is a combination of your supply and demand, how your supply and demand fluctuates. You increase the price or decrease the price based on your demand or extra shortage of your inventory. When you start having millions of products, practically to do that on a manual basis gets impossible even with your most fanciest analytics in the form of visualization and so on. So that can only help you to some extent. You need the more sophisticated algorithms to get that right. Similarly, when you start adding factors of customer demographics or retail context, you want to know the age of the person, like what Jonathan was mentioning about. He's looking for a certain kind of clothing, and he gets women's wear and so on, right? So such combinations, getting it right, needs you to know the user, about the user preferences, and also about what they are looking around, browsing, and so on. So similarly, when you go into the supply chain side of it, supply chain, if you think about today's supply chain where manufacturing is so distributed and there are multiple layers before a car is manufactured or a phone is manufactured, and the need to optimize keeps increasing. And the expectation is I need to know the information real time as well as optimize my supply chain so that my cost is the least. So if you think of the same scenario what I mentioned earlier, you have millions of parts and you want to optimize that every single day. Okay, there is a memory chip that goes in many of your products. Now that memory chip drops price. What does it mean for every single order, every single customer, and what can you optimize in a rapid manner than the traditional mechanism of running what is more commonly known as MRP or supply chain planning models, right? So these are use case scenarios which sound very disconnected from machine learning, but if you look at some of the best like Jet.com, Walmart, Amazon, they already use it. And when we talk about some of the relation to an application that I'm going to show you that's built on Google Cloud, I'll talk a little bit more about it. Machine learning, it comes to actual implementation, more broad, there are broad steps, but they're categorized into four key aspects that's shown at the bottom, right? It's about a massive amount of data, your storage, analysis, and recommendation. Now, why does Google Cloud Platform itself as one of the best platforms that you can adopt is not only for the scale, but also the speed. Speed is extremely critical. Now, I've had conversations with some of the biggest banks in New York who usually tend to have the most sophisticated technology in the world, right, for massive computation. Even they acknowledge that, it's practically getting impossible for them to have an on-prem infrastructure which will scale to the public cloud like Google. Now, let's relate all of this to something more real, right? Well, I'll show you a quick simple demo just to kind of bring the points across together. We studied all of this over last years and have worked with Google recently. We built a SaaS application which uses machine learning, and here we'll show you a very simple use case, but it will drive home the point on how, in the context of supply chain, machine learning gets applied. So I'll switch my application. Before I switch that, here is some information about us, and I'm going to flash this after the demo as well, so that you have it for further references. So, screen?
Yes.
Okay.
Yep.
So this application, what you're seeing, is completely built on Google Cloud Platform, right? It's a supply chain plane which has machine learning as well as embedded MRP and so on, right? It can scale to any volume of data. And what is more important is the ease with which the users not only can upload the data into Google storage, but also to be able to enable machine learning through simple interface. If you think about any housing example, right, and like the likes of Zillow and Realtor.com and so on, they all deal with supply-demand balancing problem. How many homes are available or not available, and which home to match to which customer, and so on. So if you think of traditional analytics, this comes with all the traditional analytics, but let's go to the machine learning aspect of it. When it's a housing recommendation, knowing which house would the customer like, and all based not only based on their recent searches, but on what others are searching and rating. So now, what you see when you go into the likes of Zillow or any of these web applications is they use machine learning algorithms and come up with the top 10 recommendations and so on. So does Amazon. You can now get the same kind of capability in a much more affordable manner for your own enterprise. And this is just a sample demonstration of how you can do that, right? Where we run through millions and millions of home inventory and what's more relevant to you and come up with a recommendation. Now, if you think about machine learning used here, like market basket analysis, as in, like, okay, what kind of homes are you looking at, right? Generally looking at 3-bedroom or 4-bedroom homes, which is like a product feature, or are you looking at homes in a certain neighborhood? Are you looking at homes with good school district? Look at these patterns in the algorithm behind the scene and come up with a recommendation. So that look at the next home that's appearing on the screen, you're likely going to pick. To relate this to a high-tech company or any retail company that you be part of, right? Your customers are looking on your commerce platform or portals in the same manner. They're looking at I'm buying a certain switch or a router or a laptop or any of the networking devices or clothing. They want you to recommend what best suits them. It could be based on price, it could be based on preferences, it could be based on their browsing pattern. They've been looking at certain kind of television, recommend what is best for me, right? Now, the way companies we have seen adopt this is it's an iterative exercise. You do it right the first time. You're going to learn a few things that go wrong in the journey, and then keep improvising, not only asset, and also the model, right? What algorithm you picked and tweak the algorithm to a point where customers say, yeah, this recommendation actually makes sense to us. So if you're interested in playing around with this application, you can go into Planning in a Box and request for a trial, and we will have that sent your email. So with that, the end of presentation from Jonathan and myself. I'll open up for Q&A.
Manju, I know there's a question in chat about, how does machine learning work? What is the basic block of machine learning? In my opinion, I mean, obviously, different people have different opinions, but I said that the basic block would be just data and algorithms you want to process. Maybe you can give your opinion.
To just add to what Jonathan said, right? How does machine learning work?
The question is, well, I was going to say one more thing. So after we say, okay, conditional on, that the cabinet is getting installed.
Okay. So let's repeat the question and the answer. So does machine learning work? What are the basic building blocks? It's really three key steps, have all the relevant data to the extent possible. The data could be structured, unstructured, it could be your customer preferences, website navigation, it could be your product, your customers' buying pattern, order history. That's the first block. Second block is picking the right algorithms, right? In one of my slides, I had shown you 7 or 8 methods of analysis, like regression, k-means, and market basket analysis, and so on. So, and when we set out recording, you can look at it again. Picking the right one. Now, picking the right one means what kind of correlation or clustering are you looking for, right? And your business problem will tell that. And that's where some of the expertise that we bring in, or the machine learning experts that you might hire, will help you apply the business use case to the algorithm that you built. And then the third block is enabling all of this on the right infrastructure, like Google Cloud, right? So that you get response based on business need, which is if you need to issue a recommendation while the customer is navigating on the website, the response time has to be half a second, right? So which means whether it's a pre-computation or real-time computation, you need to have that. So those are the three key building blocks that we see.
I've taken B off mute. So does that answer the question, or was there a follow-on question you'd like to ask? I'm happy to take folks off mute. We had a little background noise earlier, so if anyone would like to come off mute and have a live discussion with either Jonathan, Manju, or myself, please let us know in the chat, and we'll be happy to do that. Did you if anyone has feedback on the webinar or additional, if they would like to email us?
Yeah, let me share that
on there. Again, we will be. This is a recorded webinar, so we will be sending this out to you in the recorded format, which we would be have you share with colleagues who may be interested. Thank you very much for your time. Thanks, Finn.
Thank you, everyone.
And the screen will let you know where to send feedback or how to get a free trial of Planning in a Box. Thank you.
And so the meetup is very active and engaged meetup group. And you'll see some of the experts from Google on this meetup and share with you and answer your Q&A. Thank you.